My background is civil engineering, but my graduate work was in sanitary engineering. Now it's environmental, as I said before, but the point is that I got interested in pollution.
As a civil engineer, Don Mavinic set out to solve the problem of the mineral phosphate compounds clogging pipes in wastewater treatment facilities. What it led to was a discovery so innovative that it's already changing the global landscape by facilitating the recovery of phosphorus, a key element vital to our very existence. By using this untapped resource of wastewater, he and his team were able to develop a reactor process with the ability to extract phosphorus while reducing the amount we are putting back into the environment. But that's only half the story. The byproduct of their labors generated a commercially viable end product named Crystal Green, providing a limitless source of high-quality, economically recoverable phosphate for use as an environmentally friendly fertilizer. Don Mavinic, the 2010 recipient of the $25,000 Dave Mitchell Award of Distinction.
Why don't we prevent this from happening in the first place by intercepting the nutrients that are forming this in the pipes?
Struvite is the mineral name for a chemical which is magnesium ammonium phosphate, and it forms spontaneously in treatment plants where there is available ammonium and phosphate, and if there's enough magnesium present, it can form spontaneously, causing a problem in wastewater treatment plants.
When you treat the biosolids, you release the nutrients that you've actually removed. Out comes phosphorus in very large quantities. It goes back into liquid, so does ammonia. And then that liquid stream cannot be discharged because it's toxic, it's a pollutant, so it has to be recycled back to the head of the treatment plant. That's where we intercept it. I tapped into the wealth of expertise at UBC in chemical engineering, so we're going to design a fluidized bed system from the bottom up. How do we make this thing work properly, And then we just said, okay, we're going to go with sections. So we built this thing out of 4 sections and tested it, and then the little bench model became a bigger model and a bigger model, and right to full scale. Reaction is a chemical reaction, it's not a biological reaction, and it's a reaction that involves magnesium, ammonium, and phosphate. And so when they come together in a liquid environment with the right amount of turbulence and mixing energy, as we call it, molar ratios are pretty close to 1 to 1 to 1, they form. They form magically into crystals. It is a slow release, fantastic fertilizer. It is unique in the marketplace, and what makes it unique, according to the people who sell it and who work in the nursery business, is the fact it's got that magic combination of phosphorus and magnesium. And the plants love it. And it's sustainable forever and ever and ever. Well, I'll give you a good example. When Edmonton's 1 million people, roughly population equivalent of Edmonton, and we can produce about 1,200 metric tons a year of Crystal Green just for the city of Edmonton. So roughly every 200,000 people, you can then produce 500 to 600 metric tons a year.
It's not well known, but phosphorus is a very limited material on the planet Earth, and unlike energy, which comes from a variety of different sources, phosphorus is a unique compound, fundamentally tied in with life.
No one has been able to put the package of things together like we have, but it's taken us 10 years to put that package together. We have a made in Canada technology that is solving a global problem. They're buying into this technology, and not just here, but in Europe as well, and in China and so forth, Russia. We have invented a better mousetrap, and we're putting something in place it's there for the right reason. Look at wastewater as a resource, not a problem. You've got carbon in there that you can convert to energy. You've got water that you can reuse. You've got the nitrogen. You've got the phosphate you can recover and reuse it. It's a resource, not a problem.